Question. Use the principle of mathematical induction to show the following statement. So step 1, for n equals 1, left hand side equals 1 squared equals 1, and right hand side equals -1 to the power of 1 minus 1 multiply 2 1 multiply 1 plus 1. This equals -1 to the power of 0 multiply 2 over 2. This equals 1. So left hand side equals right hand side. The result is true for n equals 1. Step 2. Assume the result, the statement is true for n equals k. So we have 1 squared minus 2 squared plus 3 squared minus 4 squared plus -1 to the power of k minus 1 multiply k squared equals -1 to the power of k minus 1 multiply 2 k multiply k plus 1. So we assume this is true. We assume this equation exists. Then for n equals k plus 1, left hand side equals 1 squared minus 2 squared plus -1 to the power of k minus 1 multiply k squared plus -1 to the power of k plus 1 minus 1 multiply k plus 1 squared. Because we assume this equation exists, so we can use this guy to replace this part. So this equals -1 to the power of k minus 1 multiply 2 k multiply k plus 1 plus, here is -1 to the power of k multiply k plus 1 square. Now go ahead. Now this equals -1 to the power of k minus 1. Then we multiply -1. Multiply -1 again. So -1 multiply -1 is 1. Then multiply 2 k plus 1. Then plus, we do this way. K is -1 to the power of k. It's this part. Then multiply 2. Here is also 2 multiply k plus 1 square. Then look at here. This equals -1 to the power of p. Then multiply is 2 is -1 multiply p plus 1. Now plus is also -1 to the power of p multiply here. Here is 2. We remove the brackets. So here is 2p squared plus 4p plus 2. Then this equals -1 to the power of p multiply here 2. We remove the brackets. So here is -p squared -p plus -1 to the power of p multiply 2p squared plus 4p plus 2. Then this equals, here is -1 to the power of p multiply. We combine these two together. So it is, here is 2. The top is 2p squared plus 4p plus 2 minus p squared minus p. Then this equals -1 to the power of p multiply 2. Here is p squared plus 3p plus 2. This equals -1 to the power of p multiply, here is 2. The top is p plus 1 multiply p plus 2. So this is the left hand side. Now let's check the right hand side. The right hand side, because we just use p plus 1 to replace the n in the original term. So it is -1 to the power of p plus 1 minus 1 multiply. Here is 2. Then it's p plus 1 multiply p plus 1 plus 1. So this equals -1 to the power of p multiply 2. Here is p plus 1 multiply p plus 2. So compare the left hand side and the right hand side. The left hand side equals the right hand side. So the statement, the result is true for n equals p plus 1. The conclusion, the result is true for n equals 1. And if true for n equals p, it is also true for n equals p plus 1. Therefore, the result is true for all n belongs to positive integers by the principle of mathematical induction.